So this is Key Assessment 3 for the Lower 6 Core Concepts, and it's paper 3, and this is the Help Me video. We have a graph. Glucose concentration can be determined by using a number of tests, and this one is using a colorimeter. What have we got here? We've got glucose concentration, and up the side we've got absorbance. So that means how much light gets absorbed by the solution. And if you're not quite sure how to interpret graphs, it's always really helpful to go to 0 and go, if there's no glucose there, then we will get no light absorbed. All the light will go through. With more glucose there, then the reagents, you can imagine using a Benedict's test with a red colour as a result, that will absorb some light, so the absorbance will go up. Glucose does not appear in the urine until blood glucose concentrations of 0.18 milligrams per cm cubed, and that's to do with diabetics. When tested, a urine sample gave an absorbance of 0.17. State and explain the diagnosis. So we need to interpret this information. 0.17 arbitrary units. Well, that is that unit there. So what we are doing is we are going to look at 0.17 on this graph. So we've got 0.11, 2, 3, 4, that's 0.15, and so 6, 7. So we're going to go across on the graph there. And then down from there. So when we do that, the glucose concentration that equates to is 0.75 milligrams per cm cubed. And now all you need to do is compare that to the number for a diabetic and then make a judgment based on that. But quote your evidence from the graph. Why is it not possible to use a standard curve for glucose determination in a whole blood sample? Well, if you take a sample of blood, it will have in red blood cells. I've drawn these absolutely huge. It will have in white blood cells. It'll have in platelets. And of course the glucose, but you won't see the glucose because it's in solution. So if you try to test the absorbance of that solution, you can imagine things getting in the way and it being a problem there. So it's something to do with the actual colorimetry and light and passing light through that sample, that the answer is. Part B, we are talking about immobilized enzymes, including biosensors. 2 advantages of using these. We should have many advantages in the notes. So biosensors are really good, really, because if they're using an enzyme rather than shining light through something, think about enzymes and the shapes being specific and will only catalyze one reaction. And enzymes will also, in addition to being specific, think about the immobilized bit. What do you know about immobilized enzymes compared with normal enzymes? And there are a few other reasons as well, but there's 2 things to think about. 2 monosaccharides, spot the difference. Well, it really is as easy as spotting the difference. That's the difference there. But you need to describe it like a biologist would. So you might remember numbering carbon atoms: carbon 1, 2, 3, 4, 5, 6. So when you're stating this location, tell us which carbon atom it is and mention the actual groups or the elements that are present in whether they're kind of up or down, or below the ring, above the ring. So it's not just enough to say it's got an extra this or that, you need to be a bit more descriptive. What would be the products of a condensation reaction between these two molecules? So condensation, that is these two groups here and removing something, removing water. So, and this is products. So the product of a condensation reaction will be, well, water. So we are going to perhaps remove water there. And then what's this disaccharide that we're left with? And it's got a name. And that's 7 marks.